And we're now recording. This is Kubernetes SIG Network for January 21st, 2021. Tim, why don't you take it away with some issue triage?
You got it. Let me pick the right window. Can everybody see that?
Yep, looks good.
Yep.
All right. So I pulled it up, and needs triage was about 20. I went through and I was able to close some or accept some automatically. Let's run through them. First up, we have a bunch of test flakes. So I didn't want to assign them unilaterally. I thought we'd at least talk about them.
Yeah,
So we have. Go ahead, Antonio.
Yeah, this is to me.
You want to assign it?
Yeah.
And should we accept it?
Right. I don't know what's happening, but
All right, I'll leave it for you to accept then.
we have a lot of flakes. Like,
Yeah, it looks like that. Maybe we'll have to do something about this. All right, assign that one to you. Network policy, EDE test, connectivity information. Anyone who's on the network policy group?
Yeah, that's mine. We are enhancing the bootstrap of the network policies tests. So we're going to tackle this in the subgroup.
All right, I'll assign it to you and I will accept it as triaged.
Yeah.
Cool. Another flake. Anyone have context? Oh, Jorn is already taking it. Oh, I commented on it. Okay, cool. Services should be able to change type and ports. Another flake.
but this is the one that okay. So the problem with this is that these tests are taking more than 40 minutes, something like that.
Right. So I'll mark this accepted. Is somebody following up on it? Is it you? Is it Wojciech?
So the question, this is for people like you and Bowie, because what Wojciech says is that if we can split the test, but I went through the test and the test seems that is testing exactly that the load balancer works with both protocols at the same time.
I'm trying to remember this test. Yeah, we do. I remember we merged it all into one big test because it was very slow and it was faster to not do everything twice. But TCP and UDP, obviously, at least until we have mixed protocol support, is creating two different load balancers anyway, right? So if I recall, what the test is doing is firing up both services in parallel and then waiting for them both to complete. If we broke them into two separate tests, we could run them in parallel or we could run them in serial, right?
Yeah, and with Ginkgo, I think that all of them run in parallel. So
yeah,
if you can split, you are going to earn some time.
That seems reasonable. I guess it ends up with two slightly simpler tests, although we want to keep them roughly in sync. So I guess we parameterize the code around that. We don't want to make different test cases in different paths, right?
Yeah, I think that. I mean, if.
All right, I will accept.
Thumbs up on
I will accept this, and I will actually assign myself, and hopefully I don't just let it die. Okay. Exercise host port tests in scheduler EDE for both Windows and Linux nodes. Anyone has context on this one?
Yeah, this is so there was a test in node conformance that was doing the host port, but the problem is that the test wasn't testing that the host port was working. So it only tested that the pods were scheduled, but it turned out that the host port wasn't working and was failing. So when I fixed the test, I had to use host network path to do the checking, and this broke the Windows test. So what they say is that move this test to test host port to SIG network and keep the scheduling with host port in the node conformal.
Okay. So I'll accept this. Is anybody going to actually tackle it, or are we just throwing it in the backlog right now?
I can follow up since I created the problem.
I'm not sure that that is true, but I appreciate you falling on the grenade. Okay. Network policy tests folder. Should I just accept this one and assign it to you again, Amim?
Yep. We are removing the old network policy folder in order to replace with the netpol folder. So there are some movements in this task.
Excellent. All right. Still got some time. Great. External IP of traffic policy local. I saw that this Pavitra responded here, and it's back to the original poster for questions. So we can just circle back to this one next time. Add ability to target ingress class controller in a specific namespace. All right, so this one I wanted to discuss. The request here is really to be able to have ingress class parameter blocks that are inside namespaces. And the reason is they want to use an Istio, I think it was Istio, a something gateway, yeah, Istio gateway as the parameter block, so they don't have to define things twice, which seems reasonable, if maybe a bit clever. And now that I understand the use case, I wanted to see if somebody from Service APIs wants to take a look at this and weigh in on it.
It's funny that you that you bring this up, because if you look at today's agenda, Rob, and this is Damien, this has come across as an issue for Service APIs implementation that I'm leading, and this is exactly what I would like to see is namespace within the local object ref. I don't know if we could necessarily call it a local object ref if we're also referring to a namespace, but you know, my use case is the controller runs in a specific namespace. We utilize an existing custom resource that's namespace scoped, and we really want to get away from having to support an almost, if not identical, custom resource that we could use that's, you know, cluster scoped. So
Okay.
yeah, I mean,
so I don't personally have any major objection to this. If you think that the Service APIs is going to allow it, then I guess it makes sense to allow it for ingress class.
well, and what's interesting is so why this is a topic of discussion is I went back to our Service APIs notes from a year ago, and this exact discussion came up, and it was like, well, you know, ingress classes, you know, these parameters are cluster scopes, so let's just stick with that. We do want that consistency between gateway class and ingress class, since we expect, you know, users to potentially migrate in the future, and so we want a very similar experience there. And so, you know, long story short is the parameters ref of a gateway class is the way it is because ingress class set that precedence. So that's the only, I mean, that's from the discussions we had in detail about this over the last week or two. It's the only reason that we decided to go that route is because ingress class set that precedence.
Yeah.
All right.
I'll add just a little bit to that. When we discussed this last time,
I think it was Spring. And what we were looking at then was config maps and secrets as things that we might want to refer to as parameters. And those are both relatively unpopular use cases for namespace scope references. But this example plus the one Damien brought are namespace scope custom resources. So we've lost kind of that that baggage of referencing config maps as being the primary reason for doing this, which didn't have a lot of buy-in. I think there is increasingly compelling use cases for referencing custom resources at a namespace scope. So yeah.
I will just say that this warrants a shortcut.
Yeah.
Can't type when you all are watching me.
Danian, Danian, who wants to pick this one up? Rob? Seems like you guys are the most obvious candidates.
Yes. Rob, is this something that we want to work on together, or are you
Sure.
kind of overloaded with bandwidth? Yeah, I could definitely use the help. Just as I mentioned to you in the past, I'm like up to my ears and trying to move forward with the service APIs implementation for Contour.
Hopefully this is not a significant amount of work. Throwing the KEP together is just to show that we thought through the potential downfalls.
Yeah.
Yeah.
I think one thing
Sounds
to
good.
figure out is how to do it in backwards compatible way to reference both namespace and non-namespaced. But
Right.
Yeah, I think namespace would have to be optional, but we'll figure it out.
Okay. All right. And the last one, if we have one more minute, yeah.
Mhm.
It looks like this was fixed and then reverted.
Yes, that's correct. I'm not sure what to do with this one. Maybe the person, it looks like it's very freshly reverted, and some of the node team is still looking into it.
Okay.
Do we just want to
Should
leave
we-
it for 2 weeks?
That's fine. Let's leave it for 2 weeks and see what we have back by then.
Yeah.
Okay. All right. That one's for me. And that's it then.
Cool. Just in time.
That was fast.
Yeah.
Now, next time we can go through the backlog of bugs that are opened and already triaged. Now that will take some time.
I like your optimism. You believe we won't have a preponderance of new issues untriaged. Keep thinking positive.
New year, new mindset.
So last week we said we were going to reserve, or 2 weeks ago, last meeting, reserve 30 minutes to talk about this cluster network policy work that's been going on. So I think that we should do that. That will
Josh,
bring
can you
us
allow me to
till
share my screen?
45. Yep, you should be able to.
Okay. Okay, I hope everyone can see the screen.
Yep.
All right, so today me and Gobin and Yang, we're going to go through the proposal for cluster scope network policies. And essentially, Gobin will start off with the use cases and the motivation and goals behind this new resource. And then I'll walk through the proposal on the high level. And then Yang will go a deep dive on the sample examples and help clarify some of those nuances of the proposal. So Gobin, do you want to start? And feel free to tell me to skip slides.
All right, awesome. Thanks, Abhi. Hi, everyone. My name is Govind. I'm a product manager at Google. I'm super excited to present cluster network policy to SIG Network with Abhi and Yang and all of the other folks on this slide. I guess it's a good time to sort of introduce everyone. I guess we have everybody on the call. So does everybody want to do their quick intros, the contributors?
Okay, I can go first. Abhishek Raut from VMware. I've been working on Kubernetes for a while, integrating some of those CNI specific things with our stuff, and mainly today working on Encria.
I've already introduced myself. Young, do you want to go next?
Yeah, sure. My name is Yang, and I'm also from VMware, and I also work with abstract a lot of times to work on network policy related features in project and
Vinay?
Yeah, I'm Vinay. I'm with Google. I work on network policy and other stuff.
Satish?
Hi folks, this is Satish. I'm part of GK networking team at Google.
All right, Chris?
Hey, Chris from IBM, working on the Kubernetes project for a bit.
All right, and Zhang used to be with our project, but I think she's moved teams, so we did want to give her credit for the work that she put into this. Thank you, Zhang, for your efforts. All right, so let's start with the motivation of why we need cluster network policy in the first place. Some of this is probably well understood by all the Kubernetes bigwigs. But let's just summarize and make sure that everybody has the same understanding. Cluster administrators need strong guarantees about their cluster's network behavior. This comes as no surprise. Kubernetes is a developer-first product, developer-first API. And as enterprises get more and more serious about adopting Kubernetes, they are struggling to find the right controls and the right mechanisms to afford them the guarantees that they need. And much of it is, the network behavior as to what traffic comes in, what traffic gets denied and allowed. There's no way to make those strong guarantees today within Kubernetes. There might be ways to do it, say, externally on the VMs that they're running on, for example, but there's not really a very good way of doing this today, or any way of doing this today in Kubernetes OSS. The other sort of complementary use case to this is cluster administrators, motivation, I should say, is cluster administrators want to deploy policy at scale without worrying about when new workloads / namespaces pop up. What this means is right now, since network policy is a namespace scoped resource, when a new namespace comes up, somebody has to remember to go and add more network policies to it and make sure that the workloads are protected. With this use case or motivation, what we're trying to make more salient is the fact that an administrator may just give the cluster away to a team or a group of teams and say, you're free to do whatever you want with it. Just make sure that some baseline stuff is always there. And anytime a new workload or a new namespace comes up, these policies automatically extend to those workloads without the administrator having to remember each time to go and add them explicitly. Finally, the network policy resource today, it is a completely developer-focused API, as I mentioned. And it can be changed without the administrator's approval. And RBAC doesn't really help in this case because administrators really don't have full knowledge of each pod's connectivity needs. And RBAC is also at the namespace level, so it cannot be controlled by administrators and by the namespace owners as well. So that's the motivation that we have so far. I'll take a breather here. Any questions on this? No. Okay. So next slide, please. Thank you. There's a chat message. Let me just take a look at that. I'm not sure if I understand the comment. Sorry. Is there a question in the chat?
No, just English as opposed to American English. I'm not an American English speaker, so thank you for putting a U in behavior. I wonder who wrote that, and I was like, who learned English from England?
I happen to be Canadian, so that's why.
There you go. Thank you, Commonwealth Brothers. Thank you. So hat tip to the U in behavior. Thank you.
Okay. I was like, there's this technical question I don't understand. What is this?
Sorry. Just random ad lib from the bleachers. Sorry.
No,
all right.
We're also teasing Abhishek about his telescope also.
Oh, I see. All right, moving on. So as all of you know, network policy is, predominantly a conversation to have with multi-tenant clusters. I just wanted to sort of level set everyone and give a clear understanding of what we mean by multi-tenant clusters. In this case, there's multiple namespaces that are being deployed. in a particular Kubernetes cluster. And you can imagine a cluster administrator, giving access to that cluster, say by namespace, to each of the tenants. Tenant 1 is namespace 1, tenant 2 is namespace 2, and so on and so forth. And they have control over their namespace, and that's their perimeter and that's their territory. And the network policy happens to define the boundaries between them, because if without those policies, everybody can talk to everything. That's the basic level of multi-tenancy that everybody should have in their minds when we talk about the rest of our slides. Next slide, please. So these are the explicit use cases that we really wanted to go after with cluster network policy. So we talked about the motivations. This is how they manifest in terms of everyday use cases. So they're numbered for a reason. You'll see on the next slide how they actually look in a graphical format, but let me just talk through them first. So the first use case, explicitly denying traffic from certain sources. So this could be sort of a DOS protection based on certain source IPs. If you discover that there are some bad actors out there who are constantly pinging your services, you can write some network policy at the cluster level, and every time any workload is deployed, those IPs will not be allowed to send packets to you to give you a distributed firewall experience each time there's a new workload. Another common use case we see by enterprises is gateways for centralized security. What that means is they would like to force network traffic to go through an ingress or an egress or both gateway, when traffic is going in and out of the cluster, and this is usually to do more perimeter-based security, also to do more packet mirroring and other packet inspection use cases. Could also be L7 policy or what have you. So lots of different sort of gateway use cases, but that's not the point of this. The idea here is to use network policy as a way to sort of do guardrails and really direct traffic in a very intentional manner through the cluster. SaaS deployments that leverage multi-tenancy. This directly relates to the slide that I showed you before. Typically, many administrators in a multi-tenant system want to allow intra-namespace traffic to work flawlessly, but deny inter-namespace traffic by default. So they don't want any new namespaces to be able to just talk randomly to other namespaces. They want it denied by default. Enforce baseline security in every cluster. It's a very common thing that kubedns is required for the successful operation of your cluster to resolve both internal and external FQDNs. But if you deploy a default deny network policy, you've just killed access to kubedns. So you obviously want to make sure that some of those baseline pathways are open, and the developer doesn't necessarily accidentally shoot themselves in the foot by implementing the wrong policy. And finally, restricting egress in hybrid environments. Many times there's a database sticking out outside the cluster in your on-prem environment or elsewhere, and it's usually running in a static IP. And for legacy reasons, you only want to allow a subset of workloads to connect to those predefined CIDR blocks outside of the cluster. And make sure that none of the other workloads are able to egress out to those particular IPs as well. So that's kind of the general way we've structured this conversation. If you go to the next slide, here's where I've mapped all of the use cases from the previous slide onto the cluster to show you how a multi-tenant enterprise cluster might look like. And all of the boxes here are namespaces and the circles are pods. The first use case that I talked about was, implementing explicit deny from certain sources, so you can already filter some traffic. Second use case, which shows up in two places, both after the ingress and before the egress, is to force traffic to go through a certain path. SaaS deployments within the namespace. So number 3, you can make sure that everything talks within the namespace but doesn't talk outside of it to other namespaces. 4 is to make sure that kubedns works, so you can automatically allow list kube system access for those namespaces. And then 5 is the inverse of 1, which is to restrict egress to certain destinations only. So all of this structure is put in place by yes, you can do this with network policy, but the whole point is that cluster network policy will make sure that it never gets preempted or undone accidentally by a developer. I'll take a pause here and just ask for any questions if there are any before proceeding. Abhi, can you go back one slide, please? Thank you. Yeah, any questions up until here? No? Okay, all right, let's keep going then. So with those use cases in mind, we came up with some guiding principles and design goals to build the proposal that that we're going to present to you right after this. So our guiding principles were to focus on the needs of the cluster administrator, not the app developer. One direct consequence of this is that even though we strive for consistency with Kubernetes network policy today, we have many places where we took another way out and said, this is not the right way to do this. We're focusing on the cluster administrator. Let's do this right. And we made conscious decisions about picking the cluster administrator's needs over being consistent with Kubernetes network policy necessarily. Right after that, you'll see follow the network policy API as much as possible for a familiar experience. But as I said, we tried to be familiar, but not at the cost of sacrificing the needs that we're trying to solve. Limit the amount of API complexity by focusing on the use cases rather than building a fully comprehensive hierarchical firewall. Many of you have probably worked in network security, and you probably know what hierarchical firewalls are. They're complex. They're very, very hard to write and to read and process. And many enterprises struggle with layers and layers of firewalls at different priority levels, which they cannot make sense of after a certain point. It's very commonly understood in this industry that nobody wants to remove a firewall ever. They'll always only add firewalls, and they're so afraid to touch firewalls, they'll never delete one. So what we did was we wanted to limit the complexity of this by really just focusing on the important use cases rather than, for completion's sake, build out a fully comprehensive, priority-based hierarchical firewall. And finally, API structure should be expandable in the future. That's hopefully obvious to everyone. So the design goals that we were really shooting for, and these are the things that we don't really want to, we want to make sure that the proposal we have, adheres to them. These are the design goals we came up with. Adding deny rules to Kubernetes. Network policy has implicit deny, not explicit. So we are explicitly adding deny rules. These are our objectives with the cluster network policy. Providing baseline security that developers can override in certain cases, and providing guardrail securities that developers can't override in certain cases. So we'll go over this in more detail, and you'll see both cases of how we can provide some sort of baseline security that is always there, but can be malleable. But the guardrail security is not something that a developer can actually override. So we provide both levels of comfort. Provide the ability to select any subset of pods in a cluster. So based on how our pod selector semantic works, you can actually select anything inside the namespace, anything outside the namespace in terms of all the namespaces. Any sort of slicing and dicing you'd like to do, you can do based on this because it does apply cluster-wide. Ensure backwards compatibility with existing Kubernetes network policy. This was fundamental to our design. And ensuring cluster network policy is only accessible by the admins via proper RBAC. That was also a key decision that you'll see in our manifest in our proposal right after this. Any questions so far? Have I put everybody to sleep? I guess I have no responded. All right.
Sleep, just soaking it all in.
All right, sounds good. Next slide, please. Before we get into the proposal, just wanted to quickly call out the non-goals. This is not an effort to improve the logging or error reporting of network policy. We are focusing entirely on the cluster network policy use cases, and we're not touching the logging error reporting just yet. That's probably effort for another CAP or another independent effort from this. Node policies. We are currently.
Actually, I have a question, but I don't want to derail this presentation.
Go ahead.
How much of this is possible with one of those OPA admission control policy validation things? I mean, it's pretty clear that this is much easier to use, I would assume.
So OPA Gatekeeper can only control admission control. So you can only restrict access to certain APIs, but you can't actually influence the data path. With network policy, you can actually affect the data path. And that's the big value here, that cluster network policy will give administrators a way to control network activity as when the packets hit the metal. Does that answer your question, Bowie?
You could write a complicated OPA rule to not allow disallowed policies to be written.
Not allow disallowed policies? Well, the thing is, if you restrict a network policy access, then no developer will be able to use it, right?
I think he's saying you could like restrict some network policies, but not others. But there are still fundamental problems in that network policy only lets you add allows. You can never add denies. So there's no real way you can get deny-based policies with network policy.
Right.
Right. Okay. I was just curious if you guys looked into some of that.
Yeah, I think we did, but there are several reasons, concrete reasons for why cluster network policy does add value, even though something like an OPA Gatekeeper can restrict creation of objects with that API. But I think we've actually answered that question, I suppose. Thanks. I'm not sure whose voice that was, but thank you. So node policies is the next point. We are not tackling node policies with this. We're focusing on pods. But of course, we think of node as an extension, but we can tackle that later. New policy targets, there's a lot of discussion around being able to use services and service accounts, FQDNs, to use to create new policy types. Oops, what just happened there? Here we go. So we are assuming that much of that work will end up inheriting once those caps start taking more form. And then a cluster network policy for every permutation, that's something that we don't want to, again, goes back to our, hierarchical firewall point. We don't want to create a, massively complex priority-based firewall system. We just want to focus on the use cases to provide maximum value to our customers with minimal complexity. All right, I think at that point, I'll stop and pass it on to Avi. Any questions thus far? Okay, all right.
Thanks,
Avi,
Govind.
Thank you.
Yeah, if Govind doesn't put you to sleep, I'm here to do the job. So yeah, I think before I get into the proposal, I want to say that most of the names that we've chosen here for fields and the action and the values is up for grabs. We're not attached to those names. So I know everyone has opinions on naming, and we definitely welcome a lot of feedback, and we want to name fields which are more appropriate. So I hope Govind was able to convince you all that there is a need for a new resource in network or in Kubernetes to perform cluster scoped security policy enforcement. And so therefore we introduce a new type called a cluster network policy. Essentially, this we hope that will be part of the networking V1 APIs and start off with alpha feature. And as you can see, it has the spec, and we haven't mentioned any status for the cluster network policy because I see that Dan Winship has a kept in open up for network policy status, and maybe that's something that we can leverage or extend to the cluster network policy resource as well in the future if it makes sense. But let's focus on the spec. So you will see a lot of similarities with Kubernetes network policy. So I'm going to skip some of those similarities because everyone's aware of what they are in interest of saving some time. As you can see, the ingress and egress rules are similar to Kubernetes network policy, wherein it will tell the policy, what kind of rules apply to the applied to pods. There's a new field here called applied to at the spec level, and you'll see that we don't have a pod selector. The reason being is that we want to be able to apply policies not just to the pods, but also to the whole namespace, essentially all the pods in the namespace. And that's why we've replaced the pod selector with something called applied to, which essentially is something similar to a network policy peer, wherein you can specify a pod selector or a namespace selector to apply the policy to. And you cannot set an IP block in there because it doesn't make sense to apply policy to IP addresses. If we take a closer look at the ingress and egress rule structure, again, the ports from/to is similar in behavior or meaning to what Kubernetes network policy ports and from/to has to offer. And so I'll talk more about the new field that we plan to introduce, which is the action field. So I think it's worthy to emphasize on the fact that the action field has two overloaded meanings. One is that the value of the action will determine whether the traffic in the rule is allowed or dropped. The other meaning to an action field is that it also determines the order in which this rule will be enforced or evaluated for enforcement. So for example, when I say the order between relative action types and between a cluster network policy versus a Kubernetes network policy. So let's take a look at the three actions that we propose. The first action is the deny action. And the first meaning of this deny action is, as what it says, it will deny any traffic that matches this particular rule will not be allowed. So it will be dropped. And the second semantics of the rule action deny is that the priority or the order of evaluation for the deny rules is at the topmost. So in a given cluster, first of all the deny rules will be aggregated, and the traffic that matches a deny rule completely will then be denied. And if there is no match for any of the deny rules that exist in the cluster network policy, then it will kind of waterfall through to the next set of rules, which is that of allow rules. The allow rule, again, is a as-is rule. That is, there is no implicit isolation associated with an allow rule. The allow rule will essentially any traffic pattern that matches this rule will be allowed. Again, it will be enforced after all the deny rules or the drop rules, but it will be enforced before all your Kubernetes network policy rules. So this kind of, with the help of an allow or a deny action, the cluster administrator will be able to enforce some stricter rules in the cluster, which cannot be overridden by the Kubernetes network policies designed by developers. So that's those are the two actions which will be evaluated before the Kubernetes network policies. Any rule which has the action baseline allow will be enforced after all your Kubernetes network policies are evaluated. So essentially, the baseline allow has semantics similar to the Kubernetes network policy rules. That is, it will allow the traffic, as long as there exists a rule in a cluster network policy. If no baseline allow rule allows that traffic, then if a pod is selected by a cluster network policy, then that particular pod will be isolated, similar to the semantics that a Kubernetes network policy holds. So
I have a bit of a comment on the last slide.
Mm-hmm.
The realization of these proposals are going to be implemented by the likes of CNIs and so on, right?
Correct.
Which makes something like order as a standard construct very hard to do if it's not clearer in the API. It's just a comment, and I've known that and I've seen that before, causing some expectations and so on. So just have that in mind while you're thinking about this. Some people use weights, like, hey, weight of the rule or order of explicit order as a number given to the order. Mm-hmm. That way, the contract is clear and it's not subject to the interpretation of how you implement it.
Correct. So I think in order to ensure that the implementation is conforming to the proposal, I think we can take help of the the end-to-end tests and ensure that we have enough coverage on the end-to-end test to make sure that the order of rules is enforced correctly, and not just between cluster network policies, but between cluster network policy and Kubernetes network policies. So I think that's something that definitely we want to ensure that as part of the initial proposal, and if at all if this is implemented and approved, we ensure that the end-to-end tests take care of making sure that any CNI implementer is conforming to those this proposal.
Abhishek, can you run through the weighted proposal?
Correct. So for the weighted policies, we've also added a slide towards the end, wherein we discuss the alternates that we also thought about. We looked at prior art. Calico Andrea has global network policies which have a priority associated with it, and we've kind of outlined the reason why we did not go with that is because I think it makes more sense if you have like a UI or a dashboard where these priorities are auto-generated. But if you have to write YAMLs, it might get very complex maybe. But of course, I mean, if users have different opinions on that, maybe we can consider that and go back to the drawing table and incorporate that feedback. But we'll discuss the alternates also that we have that we considered.
So I will say to the group, I mean, I read over the slide deck a week ago, 2 weeks ago, and I found this baseline allow to be very confusing, and I asked a bunch of questions about it, and my questions were all misguided because I didn't understand what it was really doing. And once it was explained to me, I think I understand it better right now, and it's very clever, and that's both a compliment and not, in the sense that it took me a lot of thinking to really wrap my brain around it. It's a clever expression of the stacking of policies. I'm not sure if it's a good thing or a bad thing that it's clever.
Yeah, we spoke about it after reading your comments, and we thought about it, and if it took you this much time to figure that out, then maybe it's not really that clever, because it will be hard for users to decipher the actual meaning of it. So the general theme of our proposal is doing these implicit things, but maybe it seems like being explicit might be more the preferred way to go. We don't know whether that's the right answer to this, but I think that's something that we can go back to the KEP and then we can discuss the alternate.
I think clearer documentation would be step one, because just reading this here, it seems both to not understand how network policy works and to describe something that wouldn't be useful. So I trust Tim that it is very clever, but reading the words that are written here, I can't even tell what it's supposed to mean.
So I just want to bring you there is a bit of paradox happening here. The opening statement was centered around enterprises and guardrails, and it's clear that you understand that your end user, not us, right? Not them, right? Not somebody you can like say it's clever and not in the same statement. Are people who are used to the likes of F5 firewalls, Cisco firewalls, and those things are very, very specific. And I'm gonna quote your statement around nobody touches firewalls, even with that expressiveness. So just keep that in mind. I'm not saying it's right or wrong. I'm just saying if your target end user is mostly enterprises, this will not fly well with them.
So guys, I know we've only scratched the surface, but we're already over the 30-minute time that we had set for this. And we do have, I think, 4 other topics on the agenda.
So we have a follow-up on this in 2 weeks, right?
We do,
yeah. Yes.
In the meantime, do you want people to go through the slide deck and start reading it and digesting it on their own time?
Yeah, that would be helpful. We have outlined some examples in the slides, so hopefully that will help clarify some of the actions that we have used. and then we can follow up, and hopefully we can complete the discussion next week or the next meeting.
That's great. Do you want to post the slide links here again in the chat for people?
Cool. Thanks. Thanks everybody for
Yeah,
the
thanks for the time.
presentation. Excited to see the rest of it and continue the discussion. Bridget, I believe you were next to say a few words on dual stack.
I am. And that is, I put links in the doc so people can take a look. Thank you, by the way, so much to Tim's colleague. I forget his name exactly. I probably can't pronounce it correctly anyway, but your colleague who updated the KEP over the holidays. Appreciate that greatly. We think that we've met the graduation criteria for moving to beta and are going to be adding more test stuff. I'll have a PR coming in the next day or so. So if you have opinions or questions or want to weigh in, I believe Code Freeze is, Lockie, check me on this one, sometime early February.
Enhancements freeze.
Or
February 9th.
enhancements freeze, yeah. So if anyone has very strong opinions that they feel are not being met, now is the time to speak up. And I will take my questions offline.
Thank you, Bridget. We spoke about this a little bit earlier. Rob and Danian, is there more you would like to discuss on the ingress class?
I think we're good.
Yeah, I think we covered it. So Rob and I need to connect offline and move forward with the CAP.
Cool.
But yeah, thank you.
Which brings us to Dan Winship.
Yeah, so originally we had in the dual stack KEP that we were going to make the API server be dual stack, and then we were like, too much else to do, and dropped that. What were people thinking? Do we still want to eventually make the API server be dual stack and we're just doing it later? Or was there some decision at some point that we'd rather keep it single stack forever?
Right now it's dual stack. If you
No, the API server.
Yeah. If you enable the any cast address, the 0000. It listens in
it
both.
only advertises. I mean, it might bind to both IPs, but it only advertises one of them, and the service is explicitly a single stack service.
Okay, got it. Okay, then you're right.
And it only advertises a single IP address.
So we actually had a discussion on this, and the drop was purposeful because Kubernetes default service is single stack. And we kept it single stack because we did not see a reason why it should be a dual stack. And I recall this discussion because if you looked at the history edits of the PR, or the last PR I had an entry point for like an entry item, a list item for Kubernetes default service dual stack, which means the advertised address for the API server. And we talked a bit about it, and then we realized that, yeah, well, even if you choose to use a single stack service, your code can still, let's say a class, the API server is API v4 and the service you're listening to are 6, you still can go from your code to the API server using the Kubernetes default service. There was no strong point at least, that we needed that. So my take on this is, if you have a use case and we can talk about it, then by all means, let's go ahead and build it. If there is none, then there is none. And I'm sorry if KEP did not reflect that, sorry.
There was always also some complexity around upgrades, right? Trying to figure out which API server is managing that resource and getting a potentially conflicting opinion.
How does this service work? I mean, you cannot mutate that service, right?
You can. The Kube API server is supposed to eventually reset it.
There's a controller, control loop inside API server that checks if there's a default service. And if not, they just goes ahead and creates it and creates the endpoints for it.
But I mean, there's complexity here, but certainly we could come up with some way to solve this problem. Even
I was just responding to Tim's comment. So
I mean, still, I guess the question is, do we want to, or I guess you're saying you'd want to see a good use case for it first.
Yeah, a use case. It doesn't have to be good, right?
The case we were thinking
case.
of was lazy app developers who don't really want to go dual stack with their application, but they want to effectively do single stack IPv6 application in a dual stack enabled cluster. And so therefore they would not be able to talk to the IPv4 API server.
No, they can't.
Yes, I know they can't now, but that is the use case we were thinking of.
I'm not sure I understand you, man.
What do you mean?
So Dan is worried that somebody is going to somehow write an application with no instances of AF_INET in it, and everything is AF_INET 6.
Again, Dan, this has been proposed to us and we pushed back on it, but this is not going to be the only case. Anyway, that's the case that we had.
So it's not in this CAP, but it could be in a CAP in the future, and it is a separate question.
And there is the possibility that someone goes to dual stack and to IPv6 only. So we need to find a way to.
Yeah, that means somebody who built a kernel specifically without IPv4 support and try to deploy it on a dual stack cluster. I see your case.
Or we're making an assumption with dual stack that all of the pods will end up with both interfaces in them, right? We're not allowing pods at the moment to choose only one family. So even if you don't want a v4 interface, the assumption right now is that you'll still have a v4 interface. You can just choose not to use it. So the lazy developer who just wants to talk to the API server is just going to do a connect, and their underlying sockets library is going to do the right thing, right? You'd have to actually go out of your way to not use v4, which seems unlikely. Now, it seems reasonable that there may one day be a case where a v6 only pod only has v6, and then a v4 interface would not be present, and then it would fail. I would be happy to look at those use cases as they come up. I don't have any real objection to making it dual stack, but I'm with Cal in that I want to see the reasons.
Okay.
And I do believe that there is a queue, there is an update happening on the CAP soon, like a refresh on the CAP just to make it meet the reality of the changes we've done and so on. And I do apologize that we did not go ahead and remove that from the CAP. So I'll add that to the CAP updates that we're about to do, and we'll have to leave a note that this has been purposefully removed. If there is a use case come, then we can tackle it in a different CAP, and we go ahead and do it.
Cool. Danian, I believe you were next.
Yeah, thank you. So we've been using .10 as a DNS service IP for quite some time. I think it probably even predates like core DNS and so forth. We have a controller that instantiates a core DNS environment and hard codes the service cider .10 for the core DNS service. The issues that we are seeing is that multiple controllers get spun up at the same time, and there's no guarantee that core DNS can get this .10 address. And so I wanted to just kind of open it up for discussion to see if anyone else has seen this this issue. Yes. And is it wrong for us to go ahead and say, hey, all right, we've got to use just a dynamic address and not reserve .10 for DNS? Technically, it can be done, I believe, but I am concerned with the user experience of users that have been accustomed to .10.
Yeah.
And so I do wonder, like, does it make sense to maybe have an option where similar to the API server gets .1, Is it possible to do something like that for DNS, or would the better solution be just more of like an open and flexible type of solution where any user can reserve a particular address from the service side, or for maybe that references you know, a service name and namespace or something like that?
So yes, we've seen this occasionally, that something else ends up with the .10 address and then everybody's unhappy. It's been in the back of my mind for a long time that we should probably just change kubelet to take, instead of a DNS server IP, to have either the DNS server IP or the DNS service name, and use whatever IP that resolves to. And I mean, not resolve, like Kubernetes resolves to, not DNS resolves to. And then it could just be dynamic, and the DNS service wouldn't be special in any way. That seems like the most general answer. What I don't know is if other things are hard coding the IP address other than kubelet. That's the only flag that I know of.
Yeah, and I think we can get around that just with, you know, some of the operators that we use, where you can go and plug whatever address is the DNS service IP into kubelet. But yeah, I mean, to your point, we've had some internal discussions, and it's like, I think everyone's in the same position where it's like, okay, this should work, but man, you know, like .10 has been so, you know, well known that we're just afraid of breaking stuff. So that's, you know, that's kind of our mindset right now.
So I know it's within our prerogative to do that, but I just want to bring your attention that if you looked at all the bring up experiences, all the scripts, all the test, all the, not the test, the sample codes, they pretty much standardize around that. So we can change it.
as a service,
yes.
as a DNS service IP, yeah.
Yes.
Yes.
So we can change it, but we're gonna break some people and we're gonna make some people unhappy. And the answer we have will be valid, but there will be unhappiness.
Yeah. It's hilarious because the .10 was chosen as part of the like example. This is when DNS was like an optional, like, hey, look what you can do sort of thing. And it was 10.0.0.10. We thought it was cute. And that's how 10 stuck. So
and here it is, years later, still living.
Yeah. Yes. It's Hiram's law. My fear is any solution to this problem requires a change at all of those places. Either we change them from assuming 10 and instead assuming a service name, which seems reasonable, or we do some sort of like pre-allocation scheme here, right? And so let me pause for a second and pull a different topic. Antonio and I were discussing in one of the service CIDR restrictions issue about overhauling the IP allocator to not be a big old bitmap and instead be an actual API resource. If we were to go that route, it seems like you should be able to allocate an IP address and then bind it to a service later, I think. But we'd have to actually plan for that as part of the API, and it starts to look a little bit more like persistent volume claims and persistent volumes, which, you know, maybe is a step too far if this is really the only use case for it. I don't know if there are other use cases.
So I just linked into the minutes. Someone had filed an issue a while back saying that he wanted to be able to reserve some subspace of the service range to prevent it from being automatically allocated. So there are other people out there who want this for various things.
I guess that's another way to approach it. Carve off the first 16 and say these will never get auto allocated, but they can be manually chosen.
We are now 2 minutes over time.
Daniel, this is just Bowie. We've experienced this actually explicitly, so we're happy to work with you if you're gonna kind of write up a cap or work on it.
for the I'm working on that, and I have finishing a prototype with the changes suggested by Tim and Daniel Smith. So if I have time in 1 or 2 weeks, I will be able to submit something.
Can you link any of the work that you have in the notes section underneath this topic, just so I can go back and reference it?
Yeah, sure. It's
Thank
in
you.
the tab.
Yeah, Bowie, thanks for the offer. No, that's glad we discussed this. So let me kind of digest some of the information and see how we can move this forward.
Okay, if you want to pop to a thread in the mailing list too, we can collect more feedback and ideas there. Okay. Cal, are you looking for a new windmill to tilt at?
Actually, yes. So we can talk separately because we're over time. So we can talk. Yeah, I am actually looking. Yes.
Antonio, I'm sorry we couldn't get to your topic. It was pretty busy
Yeah,
meeting today.
The topic is nice. The people that want a challenge, that just chime into this bag that is open and this pull request, and if he's able to solve it, I own him 10 beers or more, because it's one bag that I was chasing for more than 1 year.
Cool. Well, I moved it to next meeting as well. So if it's still there, then we can talk about it then. Cool. So I think that wraps it up for today. See y'all on February 4th.
Thanks, everyone. Great meeting today.
Bye.
Bye-bye.